All right, so in class we started this chapter on vector functions and most of the parametric. We got to here, and we were here when we left off. So remember that on both of these, I forgot my little r right here on both of these. Okay, and one more thing to mention on this example here is this, that remember my x was cosine t, my y was sine t, and z was equal to t. And so this part right here, you know how I was telling you that it was like a circle, right? So an even more proof of this is here. I got what if I do cosine squared plus sine squared? And so what I've done there is I've squared the x and squared the y. So in our case right here, that's equal to x squared plus y squared. And you know cosine squared plus sine squared is equal to 1. So that should be a little bit more like proof to you that why we have like a circular shape. So remember we had a circular shape that was going in a circle but traveling up, like getting larger. T was growing in our circular shape, right? So that's how we were doing that. Okay, so let's go down to, that was kind of an easier one because of the circle shape. And whenever you have cosine and sine there, it creates that circle. But let's look down at this one. So in this one we have x is equal to t, y is equal to 1 over 1 plus t squared, and then z is equal to t squared. Now t can be anything. I mean, it can be negative, positive, depending on what you're using it for. You know, if it's time, then it's probably going to start at 0 and go off to infinity or whatever. But, you know, you can do negatives as well. And I mean, the problem doesn't say. So let's imagine what's going on here. All right. So if t is a negative, so if t is negative, my x value is going to be negative. If t is negative, the y value will still be positive and the z value will still be positive. So what that's telling me there on my graph that I'm going to do is that x is going to be positive or negative, but the y value will only be positive and the z value will only be positive. So I'm only going to have a graph basically in this top little area right here. I will not be going negative on the y direction. I will not be going negative in the z direction. Okay, because whatever numbers I put in for t, it only goes everywhere in the x direction. It goes out this way for y and this way for z. So these upper two octants, I can't really draw the other one, but all right. So let's talk about, so that's like kind of like my domain, or like what my x's are going to be. So let's talk about like what these are going to look like with respect to like their height, like the function themselves. So more specifically, I guess I just want to talk about this one right here. So my x is going in either direction. My y is doing its thing in a second. My z is following t squared. So z is going to be like rising really fast. This is getting pretty tall, pretty fast. Okay, but let's look at this y right here. So it doesn't matter what number you put in, positive or negative, you're going to get the same thing. So we're going to be kind of like symmetrical across the y value is going to be the same on the positive and the negative side. So it's going to be the same y value like here and here. It doesn't matter. All right. So if I pick numbers for t, 0, if I pick 0, I get 1 over 1. So that's 1. As I start picking bigger numbers, like 2, 3, 4, 5, do you see I get like 1 over a large number? So, you know, 1 over a large number, that's 1 over infinity, goes off to 0. So the y values, the biggest that the y value is going to get is here when t is 0. And then as t grows, what's going to happen to the y value is it's going to start to creep inside. It's going to get closer and closer to 0. Okay, even with the negative numbers, even if t is negative, it's going to just get closer and closer to 0. Okay, so let's do some values and see what we got. So let's make a little table. We got our t values. We got x, y, and z. Okay, all right, so let's do, how about 0? T is 0. All right, so when t is 0, I get x is 0, y is 1, and z is 0. So there's 0, 1, 0. So let's try positive 1. So I put positive 1, the x is 1, I get a 1/2 here, and I get a 1. Well, if I do negative 1, I almost get the same thing. I get a negative 1 here, but if I put a negative 1 into my equations over here, it's really the same thing as the positive 1 answer because they're squaring out, so 1/2 and 1. So what happens there is I have to graph the point 1, 1/2, and 1. So I'm going to go 1, I'm going to go out 1/2, and then up 1. So I'm going to do it like about there. And then I have to go negative 1, out 1/2, and up 1. So it's hard to graph, 3D on here, but it's going to be like here and here is what I'm going to do. But those are on the right side of the y-axis. All right, so let's do 2. So I would get 2 here, I would get 1/5, and I would get 4. So I do negative 2, I get negative 2 there, but I still get 1/5 and 4 here. So let's see. 2 would be out here. Then I go 1/5, so I'm even closer in, but then I am up 4, so like maybe about there. On the other side, I'll go to negative 2, out 1/5, and up 4. Okay, so I'll put it about like here and here. All right, and I'll show you in a minute. There's a program you can use to help yourself out. All right, let's do like 3 and negative 3. So plug in a 3, I get a 3. Plug in a 3, I get 1/1 plus 9, so 1/10. And then I get 9. I get negative 3, 1/10, and 9. So those points would be like in here, but even closer to the ZX plane. All right, so it kind of goes like this and comes out and goes back over there. Whoopsie, I didn't hit any of those points. Oh, goodness, I don't know if I can erase it good. All right, so what happens, this is the farthest point it comes out, but then it pushes in towards the ZX plane. So let me show you. If you go into Google and you type in what I have at the end of the notes here, if you type in, what's it called, plot parametric equations of a vector or parametric curve grapher, the best one to use is this one down here, parametric curve grapher, Christopher Chudzicki, I guess it is. Anyway, that's the best one I found. So the one that we've just done is this orange one. You can see I have the equations down here, and the only thing you have to do when you type in those equations, ignore the blue one for now, that's for the next thing. You have to go to the bottom and hit redraw, and then it draws it for you, all right? So look at that, look at the orange one. See how the 0.010, that orange tip at the bottom there, is the first one out, and you see how it kind of like scoops in towards the XZ plane. It's not turning negative, so it's not on the left side, it's not on the bottom, nothing there, but it's almost like a parabola shape, and it's like pushing as it gets taller, it pushes towards the XZ plane. So that's about the best I can do for you there. All right, so let's go to this last part here. Okay, in this next example, we have find the vector equation and parametric equations for the line that joins the segments P to Q. So I want to go P to Q, so it's just a line, so parametric equation of a line. So I need the direction. So my direction vector from P to Q, let's see, 6 minus negative 2 would be 8. Negative 1 minus 4 is negative 5, and 2 minus 0 is 2. So there's my direction vector. And so we just want an equation of a line. So I'll do R of t equals, and I'll do 8. So I'll do 8t, and let's use this point right here, minus 2. And then negative 5t, and let's use 4. And then 2t plus 0. So what you have to do here is you have to tell me the values of t that you want to use, or that you want this to go from. So let's inspect this a little more. It joins P to Q. So if t was equal to 0, if this was 0, if this was 0, and this was 0, I would get negative 2, 4, and 0. It would be that point right there. So if t equals 0, I get the point P. And if t equals 1, if I put a 1 here, notice I get 6. If I put a 1 here, notice I get negative 1. If I put a 1 here, notice I get 2. So if t is 1, then it goes to Q. So I want to segment, so I only, right? Oh, just a line, whatever. Okay. Anyway, so what we're going to do is going to say to ourselves that t is going to stay between 0 and 1. Okay. Actually, I meant to insert that word segment right there. I meant to say line segment right here. That's why I was thinking that. So insert segment. So if I want to segment, so what's going to do, it's going to start at P and go to Q and just stop there, because it's going to start at t equals 0 and stop at t equals 1, and it'll be that segment from one to the next. All right, so this last example here, find a vector function that represents a curve of intersection of the cylinder. So we have a cylinder, so let's draw that. So we have a cylinder about radius 1, so it comes down, it's going along the z-axis, right? Because z is missing. Okay, and this plane. So notice this plane does not mention x, okay? So I want to see where these two things intersect. So a lot of good things to do sometimes is to like kind of find the intercepts. So x isn't mentioned. So what that means is that this plane is going to travel in the x direction, like always. It's going to go forever in the x direction, one way or another. So I don't need an x. X is going to be whatever it is. Let's pretend that y is equal to 0. Well, then z would be 2. So there's my z-intercept. So it crosses the z-axis right here, the plane does. And then, like I said, x can be anything. Let's pretend that z is 0. Well, that means that y would be 2. So I'm plugging that information into here. So it touches over here on the y-axis at 2. So the plane is coming across and like slicing through this cylinder right there. And remember, we said it's traveling in the x direction all the way back, all the way forward. So if you can imagine by that annoying picture there that we're slicing this off. So imagine you had like a sausage or a salami or a soda can or I don't know, like a Pringles can or something, and you came through and you sliced it through like in this plane. You would get a circle, but it would be slanted, right? Like it would be kind of at an angle. All right, so I'm going to draw this for you in a second, like on that graphing system there. But this is what's going on. You know, you have like the cylinder shape, and somebody has come through and they've like sliced off this thing. So it's like slanted, but it's still circular. Okay. All right. So remember, if you want something circular, then we're gonna have our what we had earlier with the cosine and the sine. So remember, x squared plus y squared equals 1. We could substitute in cosine squared plus sine squared. Oops, I meant that to be a t. Sine squared equals 1. So that what we're going to do is let x be cosine, y is sine, and I've been given something that I can find z because I don't have a z in this problem. What I've been given is this equation over here. Y is equal to 2 minus z. So that means y, wrong way around, sorry, my bad. So z, I wanted to solve for z, not y, I already have y. Z is equal to 2 minus y. So z is actually equal to 2 minus y is sine t. All right, so 2 minus sine t. All right, so we have that circular shape, radius 1, and we have the z traveling along the path of this, what's it called? This plane right here. Okay, that's my z value. It's going up and down along that path. All right, and so there is the equation, the parametric equation of the function, the intersection of the cylinder and that plane. So let me show you on the app here. Oh no, oh there it is. All right, so this is the blue one. Okay, and you know, I turned the drawing off so it's I can put it back to animate and then, you know, redraw. So then you'll see the little curve like following it, the little blue thing. So that's the t value. And notice over here, the t value is changing, that little blue number that's changing. So look, it's circular when I look up and down, but when I look this way, that's the angle because the plane was like slicing through. See the 2? It's crossing at 2 on the z-axis. Okay, and then if I extended that, it would come over the plane and cross over at 2 on the y-axis as well, but it doesn't go that far. All right, so there's that circle being there, and so the z value is following the angle of the plane, but the x and the y value are a circle. There it is right there. Okay, all right, so that is it. And remember then you have to do, this should be 12.1 in the various online, and then 13.1 in the actual hardcover textbook. And remember, to 1924, all you have to do is match them. You don't have to do anything else that the book says. All right, that's it.